When solving an equation with variables on both sides of the equal sign, I need to add or subtract one of the variable terms so that I only have a variable on one side of the equal sign. In this first example, 2x plus 3 equals 4x minus 19. I can either subtract 2x from both sides of the equation, or I can subtract 4x from both sides of the equation. Let's go ahead and try both of those strategies. So one strategy is to subtract 2x from both sides of my equation. On the left-hand side then, I have 2x plus 3x minus 2x. 2x minus 2x is 0, so I'm just left with 3. Now I only have a variable term left on the right-hand side. 4x minus 2x is 2x, and now I have my entire equation, 3 equals 2x minus 19. Now I just perform inverse operations. So in order to isolate x, the first thing I need to do is add 19 to both sides. 3 plus 19 is 22. And then I'm going to go ahead and divide both sides of my equation by 2 to undo that multiplication by 2. And that division bar is fine, but I'm going to use the division symbol. So I get my solution, x equals 11, which I prefer to write the variable on the left, but there's not really a lot of space here. So x equals 11. Now let's try subtracting. This is the same exact equation, but let's try subtracting the 4x from both sides first. 2x minus 4x is negative 2x. Negative 2x plus 3 is my left-hand side. On the right-hand side, now I have 4x minus 19 minus 4x. 4x minus 4x is 0, so all I'm left with is the negative 19 on the right-hand side. This was the goal, to only have a variable term on one side of the equal sign. My first inverse operation now is to subtract 3 from both sides of the equation. Negative 2x plus 3 minus 3 leaves me with negative 2x. Right-hand side, negative 19 minus 3 is negative 22. Last inverse operation is to divide both of the sides of the equation by negative 2. Negative 2x divided by negative 2 leaves me with x. Negative 22 divided by negative 2 is 11. So you will see, even though I solved this in a slightly different way, I ended up with the same solution. The solution to this equation is x equals 11. What you'll notice is our tip at the bottom says that we suggest adding or subtracting the smaller variable term. That would mean in this case that we subtract 2x rather than 4x. This allows us to avoid negative coefficients. And negative coefficients, like negative 2, are a source of small errors on the part of students. So we suggest that you choose this first one, that you subtract 2x first. That leaves you with a positive coefficient and less opportunity for mistakes. But it's totally fine if you just want to subtract the 4x. That works too. You get the correct solution as long as you solve correctly. Let's go ahead and practice some more. 2x minus 1 equals negative x minus 10. Now using our tip, should we subtract 2x from both sides or should we add x? Here we suggest that you add x to both sides of the equal sign. Negative 1 is a smaller number than 2. 2x plus x gives me 3x minus 1 on the left-hand side. Negative x plus x is 0, and then we're left with negative 10. Inverse operations. We're going to add 1 to both sides. That gives me 3x equals negative 9. Final step is to divide both sides of my equation by 3. 3x divided by 3 is just x. And negative 9 divided by 3 is negative 3. Negative 3 is my solution to this equation. And I can perform the check just like I normally would. Does 2 times negative 3 minus 1 equal negative 3 minus 10? That would be negative 6 minus 1 is negative 7, and that does equal 3 minus 10. Last example, should I add 7x or should I subtract 3x? The smaller variable term is the negative 7. Negative 7 is less than positive 3. So I'm going to suggest that I add 7x to both sides, although subtracting 3x would work just as well. Negative 7x plus 7x leaves me with negative 15 on the left-hand side. 3x plus 7x is 10x, minus 15 on the right-hand side. Let's add 15 to both sides of our equation. Negative 15 plus 15 is just 0. 0 equals 10x. This is an example of an equation that often causes students a little bit of confusion. They're a little unsure what to do when facing a 0, but it's okay. We still just undo that times 10 by dividing both sides by 10, and 0 divided by 10 is just 0. The solution to my equation is x equals 0. We can see when we check that this is true. Negative 7 times 0 is 0. So on the left-hand side, we have 0 minus 15, which is negative 15. On the right-hand side, 3 times 0 is 0, and 0 minus 15 also gives me negative 15 on the right-hand side. I'd like to point out again a strategy that is not accepted in Algebra 1. So it is not okay to move the 2x to the right-hand side, making it negative, and then move the 19 to the right-hand side, making it positive. This may seem like a great strategy to you, and it does lead you to the right answer, but it is not considered acceptable work in algebra. So this technique or trick of moving the terms from one side to the other, not justifying why you're doing so, is not accepted. Again, you're erasing this habit from your brain, and you are solving using inverse operations. Whatever you do to one side of the equation, you do to the other.